differentiating and substituting the x value in, and then c is found by substituting the x and y values of a point on the line. Okay, lovely jubbly. So you should be able to give the full equation. So for the curve y equals x squared plus 4x plus 10, find the equation of the tangent at the point where x is 1. Now, they've been a bit mean here because they've only said to find the gradient where x is 1. What I said up here, in order to find c, we do need to know a full coordinate. So the order that you do these things is not important, but at some point you're going to need to find the corresponding y value when x is 1. So maybe that's a good idea we do that first. So when x is 1, y is 1 squared plus 4 times 1 plus 10. Because this is going to give you the full coordinate. Okay? So we've got 1 squared is 1 plus 4 times 1, which is 4, plus 10, which is 15. So we now know that our coordinate is 1, 15. So that's one piece of information. So if they've given that to you in the question, you're high and dry, but otherwise you're going to need to do that extra little bit of work. Now, they've talked about the equation of the tangent, so we're going to have to differentiate. So we're going to have dy dx. We're differentiating term by term. I'm not going to ask you all to do it because I'm quite sure you're confident with this one. So this is 2x plus 4. Remember, any constant terms that we have, like the 10, just disappear. So we found an expression for the gradient of the tangent. So we're now going to say, well, when x is 1, dy dx is 2 times 1 plus 4, which is 6. Alright, so we know that the value of m is 6 in this case, because that's what we just found here. So my equation is going to be y equals 6x plus c. Well, obviously I can't leave it like that. I need to find the value of c. So it's at this point that this coordinate comes into play, because we know that's the coordinate that the graph goes through. We know that this is the x value and this is the y value. So we're going to stick those two in. So we're now going to say that 15 equals 6 times 1 plus c. Okay, so we've stuck that coordinate 1, 15 in. So 15 take away 6 will give us c. c is going to be 9. So at this point here, we'd stopped and said that it's y equals 6x plus c. Now we've found the value of c, so we can stick that in and finish off. So we know that it's y equals 6x plus 9. Equations of normals. Now, have you ever heard of a normal before? Equation of a normal? No. Okay. So, I've said we know. Obviously, we maybe need to cross that we know out. So, the relationship between tangents and normals is that a tangent and a normal meet at 90 degrees. What that means is that their gradients are perpendicular to each other. Now, you may or may not recall that if we have perpendicular gradients, that those gradients multiply to give -1. Now I could be saying all of this stuff to you and you're thinking, oh my goodness, what is she on about? But it's actually pretty straightforward. If two values multiply to give -1, it means that they are negative, oh shush now, they're negative reciprocals of each other. Okay, this word, negative reciprocals of each other. So if the gradient of the tangent was 3, the gradient of the normal, do we remember what a reciprocal is? kind of over 1. It's essentially the inverse. It's upside down. Okay? But notice it's negative reciprocal. So if our gradient was 3, it would be negative 1 over 3. Yeah? So it's not tricky. Whilst it sounds crazy and all fancy, it's actually not difficult maths. You're finding the reciprocal and changing the sign of it. If the gradient of the normal was 2/5, the gradient of the tangent would be negative 5 over 2. Yeah? So whichever one you're given, it doesn't matter. You're just going to invert it and change the sign. So, that process we've just done to find the equation of the tangent, we differentiated. We stuck a value of x in. That gave us the gradient of the tangent. So if they've asked you to find the equation of the normal, the only thing you're going to do is at this point here, in that process that we've just been looking at, instead of saying it's going to be y equals 6x plus c, you would say it would be y equals what? Negative 1/6x plus c. And the rest you then carry on. Okay? So that process is exactly the same. You just have to do one minor extra step. Okay? So let's do an example of it. So find the equation of the normal to the curve with the equation blah blah at the point when x is 2. Okay, they've been asked us again and only given us the x value. So let's first of all find our y value. So when x is 2, y is 2 squared minus 3 over 2. Oh gosh, we've got fractions, people. So that's 4 minus 3 over 2. So if this was on the non-calc paper, okay, you've got to be confident enough to work with these. We've got fractions. What's the rule when we add or subtract fractions? What has to be the same? The denominator. So I have 4 whole ones here, and I ideally would like a denominator of 2. So secretly this is over 1. So how would I change this here? This would become, so we'd multiply both things by 2. So this would become 8 over 2 minus 3 over 2. Yes, all happy? Which gives us 5 over 2. Okay, so we found the value of y. Yes, it's an improper fraction, but we can leave it like this. Okay? Alright, so we found our coordinate is 2, 5 over 2. Lovely, jubbly.